Hello everyone, this is Jessica from For Other Prizes Consulting, and I wanted to go over the math that I had done in my demonstration to the song Ain't It Fun by Paramore. Now the first problem is considered a prime factorization problem, which means I will take a number and break it down to its prime factors. In this case, I chose the number 56. So Paramore's song says, I don't mind letting you down easy. And in this case, I drew a line down because knowing that when you're doing prime factorization, you're getting ready to draw your factor tree. And eventually, what Paramore says in the song is, you're not the big fish in the pond no more, you are what they're feeding on. So I thought about when I broke down each part of 56, I noticed that everything started getting smaller and smaller to the point where I reached my prime factors. And in a sense, you could say that these prime factors, these smaller numbers, are feeding off of 56. For the next problem, I went off the part of that song that says, what are you going to do when the world doesn't orbit around you? So when I think about orbit, I think about a circle. So in this case, if you look at the square as the center, and the circle around it is orbiting this square. And in this case, your question here is, what is the area of the shaded portions when the area of the square is 64? So you can tell that the area of the square is 64 because this side is 8 and this side is 8. And the area formula for a square or rectangle is length times width. So in this case, it's 8 times 8, which is 64. So here I know that I have a 45, 45, 90 triangle just because in a 45, 45, 90 triangle, one side, well, the two sides that are not the hypotenuse are equal to one another. So I know this is 45, 45, 90 triangle. The hypotenuse here would be 8 square root 2. Okay, so now we're looking for the circle area, and the first thing we'll need to find the radius. So we know the radius is actually half of the diameter. So I'm going to write 8 square root 2 divided by 2. That gives me 4 square root of 2. And with the area formula, we also know that there's going to be a pi on the side and that the radius will be squared. So when I square the radius, I get 16 times 2, because what's inside the radical comes out and the radical disappears, and I have pi on the side. Then I work out the problem some more. This turns to 32 pi. And so going back to the question that asks what is the area of the shaded portions when the area of the square is 64, well, I know the only way I'll be able to find that problem is to subtract the 64 from the overall area of the circle. So this is the overall area of the circle. And I just place a minus 64 because that's just as far as we could go. Okay, for the next problem, which asks, how many ways can the gold, silver, and bronze medals be awarded amongst 11 Olympic participants? I will first have to guess what type of problem this is and what type of formula I would need to use. And I can tell that this is a permutations type problem because permutations problems ask how many ways can something be arranged in a particular order. So as you can see, gold, silver, and bronze, that's that order: first, second, last place. And there are 11 Olympic participants. This correlates to the part of the song that says, where you're from, you may be running things. And what I did here is I started placing numbers here. And then the song says, where you can ring just about any bell and get what you want. And so just to be creative, I put a bell shape around the 11, 10, and 9. And the fact that the reason I only put 11, 10, and 9 here is that you have to consider for the gold place, how many participants do you have who could potentially qualify for the gold title? And that's 11. So once the gold title has been taken away, you have to ask yourself the question, how many would be left over to potentially claim the silver title? And that's 10 participants. And then after you take that away, you have to ask yourself how many would potentially be able to claim the bronze prize, and that would be 9 participants. And so you're multiplying these together to get 990. And this is a part of the song where Paramore says, it's easy to ignore trouble when you're living in your bubble. And this is how I worked out the problem. Okay, for the fourth problem on my board here, is asking what is the length of BC when diameter of circle O is 10. And at this part of the song, Paramore is repeating the lyric from the previous verse that says, what are you going to do when the world doesn't orbit around you? So in this case, I drew a circle. Because again, I'm thinking orbiting is a circle. And notice that this triangle is called triangle U. So again, being very creative there. Assuming that this triangle is U and the circle is orbiting around triangle U. So then I'm looking for the length of BC. And what I notice here is that I'm dealing again with a 45, 90 degree triangle. And the reason I know I'm dealing with that is that the radius right here, this is a radius and this is a radius, which is the point from the middle of the circle. I'm sorry, my circle doesn't look too symmetrical, but assuming that this is the center of the circle, any point coming from the center of the circle to the outside of the circle is the radius. So I could say the radius is coming from A to B and the radius is coming from A to C. So that tells me that AC and AB are of equal length. So this problem is telling me that the diameter of circle O is 10. And if I know that the radius is half of 10, then I know that the radius is 5. So I put a 5 right here, and I put a 5 right here. And given what I know about the 45, 45, 90 degree triangle, anytime the other two sides opposite or that are other than the hypotenuse are the same, that means the hypotenuse is going to be this number times the square root of 2. So in this case, I've gotten for my answer, BC equals 5 times the square root of 2.